Hello, I'm Papia. In this problem, we have to find the particular solution of this given differential equation which satisfies this initial condition. So, the first step is take this equation and then separate the variables. You see that x and y, they're two different variables and they're all written together. So, you have to separate them first. How to do that? It's not very difficult. You see, if you multiply this entire equation by 4y, you will not have y on the right hand side. So let's do that. So we'll have 4y dy. Now here's the thing. We will have x in the right hand side and we have this dx in the left. So why don't we bring the dx on the right as well? So keep the dy. Right hand side will have x ln of x cube, and this dx we can bring in the right. And see, we have separated the variables. Left hand side all y, right hand side all x. Now we can integrate both sides and we'll have a solution. So let's integrate. Okay, so for the left hand side, you pull out 4 and you will have integral y dy. Right hand side, you have x times natural log of x cube. Notice that natural log has this property that ln of x cube, since this 3 is in the power, ln, natural log, brings the power down. So this is same as 3 times ln of x. So if you simplify that, it will be easier for you to integrate. So let's consider this is 3 times ln of x, and then you can pull the 3 outside of the integral, and you will just have to integrate x times natural log of x dx. Okay, the left hand side is integral of y dy. You can just use power rule and it will be y squared over 2. But what happens to the right? Look, this is x times natural log of x. Two different types of functions is sitting as a product. So what kind of rule can we use to integrate this function? Recall that we have to use integration by parts. Okay, so let's try to solve this integral separately. So we have to integrate x ln x dx. Integration by parts is a method where you have to first separate the functions into u and dv, and then we use the by parts formula. So you have to choose u and you have to choose dv from this given function here. So there are two different functions you have. You have an x and you have a natural log of x. Which one do you want to choose as u? Well, notice you want to choose u to be something whose derivative can be computed. Well, that's not so difficult. The difficult part is what you choose as dv, because whatever you choose for dv, you have to integrate that function. So between these two functions, x and ln, which one can you integrate easily? Of course, x, not natural log. Okay, so the best idea is to choose u to be natural log of x and dv to be x dx, because you can integrate x easily and you can differentiate natural log easily. So once we do that, from here calculate du, that is 1 over x dx, and v is integral of x dx, so x squared over 2. And of course we ignore the constant of integration here. All right, so use the integration by parts. So we have divided it into u times dv. By parts says this is equal to u times v minus integral v times du. All right, let's write down everything. U is ln of x, v is x squared over 2 minus integral v is x squared over 2, and du is 1 over x dx. Okay, so first term, we don't have an integral, so you just keep it as it is, x squared natural log of x over 2, minus, you take out 1/2, and notice inside the integral, you have x squared divided by x. So you can cancel one of them, and you will just have x dx. Again, keep the first term as it is, and just integrate x dx, that's x squared over 2. So this is the antiderivative, and we can just plug it back here. So we have 3 times x squared natural log of x divided by 2 minus x squared divided by 4, and then you have your constant of integration. All right, so we have solved the integrals, both of them, and we have a general constant. So this is a general solution to this differential equation. We have to find the particular solution that satisfies this initial condition. Now, what this initial condition means, see, it says y of 1 is 2. That means when x is equal to 1, y is equal to 2. So all you have to do is plug in those values in this equation and solve for c. That will give us our particular solution. Okay, so let's do that. First of all, notice that we can cancel the 4 divided by 2 here. So we have 2y squared is equal to 3x squared ln of x over 2 minus 3x squared divided by 4 plus c. Okay, let's plug in y equals 2 and x equals 1. So we get 2 times 2 squared is equal to 3 times x is 1. So we have 1 squared natural log of 1 divided by 2 minus 3 times 1 squared divided by 4 plus c. Okay, note natural log of 1 is 0. So this term will become 0. So we will have 2 squared is 4 times 2. We have 8 is equal to, this is 0. So we'll have a negative 3/4 plus c. Okay, this gives you c is equal to, just take the negative 3/4 on the other side, 8 plus 3/4. So 4 times 8, that's 32 plus 3, 35 divided by 4. So in order to find your particular solution, you needed that value of c that will satisfy this initial condition, and here is the value of c. So now that we have the value for c, we can figure out the particular solution that we're looking for. So we have our general solution right here. You just plug in c and you will have your particular solution. So let me finish the problem here. So I'm writing my particular solution. Okay, so take the general solution. 2y squared is equal to 3x squared natural log of x divided by 2 minus 3x squared divided by 4 plus, instead of c, you write down 35 divided by 4. Okay, let's rewrite one more step. So what I can do is I can divide by 2 both sides. So y squared will be free of any constant. Okay, so we'll have y squared is equal to 3x squared natural log of x divided by 4 minus 3x squared divided by 8 plus 35 over 8. Now notice one more fact. Remember when we started the differential equation that was given to you? We had natural log of x cubed, and we used the property of natural log to bring it down, that exponent, and we had 3 ln of x. Look, in our answer, we also have 3 ln of x, if you bring the 3 next to natural log. So we can use the property again to rewrite it as ln of x cubed instead of that 3. And that way, it will look very similar to the function that we started with. So let's do one more step here. So we'll have y square equal to x square ln of x cubed. So instead of writing this 3, I'm taking it to the power of x, divided by 4 minus 3x squared over 8 plus 35 over 8. So this is our particular solution for this differential equation that satisfies the given initial condition. Thank you.